Hello everyone, welcome back to our channel. Today I want to share with you electric potential and capacitance short answer questions. According to new model from the Telangana state, we are expecting more short answers from this electric potential and capacitance. In this only 5 S.A.Qs are there. From that they have given 2 S.A.Qs we are expecting from this. So here our first short answer question is, derive the expression for electric potential due to point charge. First of all, what is the electric potential? The amount of energy required to bring the unit positive test charge from infinite distance to particular point in the electric field, that is called the electric potential. Suppose in our daily life also we want to get one body from there to here, what do you say? Force is acting like this. Like that here, the amount of work is required to bring the unit positive charge from infinity to particular point in the field is called the electric potential. So practically how can you show here? Look, we are taking one charge is there, we are placing at point A. This is the point A and this is the charge Q. And you can consider few points, otherwise you can take first point O and this is the point A and this is the point B. From here to here, O to A, the distance we should consider x. But comparing with OA, the distance between AB is the fraction of this one, means this distance we can take it dx. And the distance between O and B we are taking R. Just now I said what is electric potential? The amount of energy required to bring the unit positive test charge from infinity. So we are taking one unit positive test charge from infinite distance, that we can take it Q0. Don't confuse here. Look, now we feel this unit test charge is at point A. Then what is the distance between these two x? From the Coulomb's law, how much force is acting between Q and Q0? Now you can take Q0 is at point A. Distance is the x. From the Coulomb's law we can write it F equals to 1 by 4 pi epsilon naught Q0 by the distance is the x square. So now the charge is at point A. Now we want to move this charge Q0 from A to B, fraction of the distance. So how much work is required to move this unit positive charge from A to B? Work done, fraction of work done, not entire work done. dW equals to, we know that F dx cos theta. Here, but theta is here 180 degrees while it is moving opposite to the field. So angle between force and displacement is how much? 180 degrees. So dW equals to force into displacement. Instead of cos 180 we are writing minus. So first step is from the Coulomb's law we are writing the expression for force. Then we are using a work done formula, force into displacement. Don't confuse why we are taking minus. It is moving opposite to the field. That too angle is 180 degrees. Instead of cos 180 we are writing minus. Now we know the work done and force. But our question is to derive the expression for the electric potential. What is the definition? We want to bring the unit positive charge from infinite distance. Look here, infinite distance and to the particular point in the electric field. From here to here, how much distance is there? R. So initial point is at infinity and final point is at R. So how much work is required to bring unit positive test charge? Look here, integration, entire system. From where you are bringing? From infinite distance. To what distance? R. Look here, lower limit is, starting point is infinity, then upper limit is the R. How much work done? We don't know about this work done. We are calculating. That's why we know the fraction of work done dW. So integration of dW is giving the how much work is required to bring the unit positive test charge from infinity to point B. Now look, instead of work done we are writing infinity to R. dW is the force into displacement, minus F into dx. Minus F into dx. Then work done equals to minus infinity to R. Instead of force, from the Coulomb's law 1 by 4 pi epsilon naught q naught by x square into dx. Here 1 by 4 pi epsilon naught is a constant and q naught also constant. So work done equals to, we can write it, minus 1 by 4 pi epsilon naught q naught, otherwise directly we can write it q naught by 4 pi epsilon naught integration of 1 by x square into dx. Limitations are infinity to r. Don't confuse, we are doing the differentiation only for 1 by x square. But integration of 1 by x square into dx formula is how much? Minus 1 by x. Minus 1 by x. Then we are writing that limitations infinity to r. Look here. Work done equals to minus into minus plus. So we are writing 1 by 4 pi epsilon naught into, first we can apply the upper limit. Instead of x we are writing r. Minus, then we are writing infinity. You know that 1 by infinity value is the 0. So total how much work is required to bring the unit positive charge? q naught by, otherwise we are writing 1 by 4 pi epsilon naught q naught by r. Why we are not writing 1 by infinity? That value is 0. But many people are confusing. Here we got the expression for how much work is there, but we want the potential. What is the relation between potential and work? Look here, V equals to W by Q naught. Instead of W we are writing 1 by 4 pi epsilon naught Q naught by R divided by Q naught. Here Q naught cancel. The final expression for electric potential is what? V equals to 1 by 4 pi epsilon naught Q by R. This is the electric potential due to a point charge. Second S.A.Q is derive the expression for the electrostatic potential energy of two charges system, not number of charges, two charges system. For this we can take two charges, one is the Q1, another one is the Q2. Q1 is at point A and Q2 is at point B, but Q2 is bringing from infinity distance. The distance between these two charges is how much? R. R is the distance between these two charges. Look here. In previous question, you know that what is electric potential due to point charge, like that. What is the electric potential due to Q1 at point B? How much distance is there? R is there. So we can write it V1 equals to 1 by 4 pi epsilon naught Q1 by R. I am repeating this step. Look here. Electric potential due to Q1, not at Q1, at some distance. How much distance? At distance R. What is that expression? V1 equals to 1 by 4 pi epsilon naught Q1 by R. Then come to our charge 2. This Q2 is bringing from infinity to here. How much work is required? Work done formula is potential into charge. But already you know that how much potential is there at point P, at point B, V1. How much charge you are bringing from infinity to here? Q2. So instead of V1 we are writing 1 by 4 pi epsilon naught Q1 Q2 by R. But this work is stored as a potential energy. So instead of W we are writing U equals to 1 by 4 pi epsilon naught Q1 Q2 by R. Don't confuse. Electric potential is only 1 by 4 pi epsilon naught Q by R. Potential energy 1 by 4 pi epsilon naught Q1 Q2 by R. So this is the potential energy of two charges system. And this is very difficult in other materials. Better in description box I am giving the simple notes also. You follow that. Then our third short answer question is, it is very important. See, in previous electric charges and fields, what is the torque acting on electric dipole placed in uniform electric field? So for this what we are taking, look here. This is the uniform electric field. Of intensity is how much? E bar. And we are placing one electric dipole of length is 2a. Electric dipole means it is having two opposite charges, maintain some distance. That arrangement is called the electric dipole. Then what happens? One force is acting this direction, EQ. Another force is acting EQ. So two equal and opposite forces, two equal forces are acting in opposite direction. Then what happens? Any system will rotate. Rotate means we can calculate the turning effect of force is called the torque. Here no need of deriving the turning effect of force, but we should remember that from the electric charges and fields, torque tau equals to PE sin theta. PE sin theta. But our question is potential energy, nothing but work done. How much work is required to rotate that electric dipole in uniform electric field? So work done, what we are taking? dW. First we can go through the small fraction of work done. dW equals to tau into d theta. Like work done equals to force into displacement. Like that in rotatory motion, work done equals to turning effect of force into d theta is the angular displacement. But now we are calculating how much work is required to rotate the electric dipole from theta equals to from 0 degrees to theta. You can take from theta 1 to theta 2 also, nothing is there for difference. 0 to theta we are taking instead of this dW. Now work done equals to integration of, instead of dW, tau into d theta. Tau, you know the expression PE sin theta into d theta. Limitations are from 0 to theta. Then work done, here PE is constant. Integration of sin theta is what? Minus cos theta. Then limitations are 0 to theta. Then work done equals to PE into minus, we are writing outside. As usual, instead of theta we are writing upper limit theta minus, then instead of theta we are writing lower limit 0 degrees. Cos theta minus cos 0 degrees. If you want to follow better, you can take theta 1, it is very easy to you. Theta 1, theta 2, theta 1, theta 2, here also theta 1 lower limit, theta 2 is the upper limit. First we are getting the upper limit theta 2 minus theta 1. So finally, how much work is required? It is stored as a potential energy. So you can get it, U equals to PE cos theta 1 minus cos theta 2. Cos theta 1 minus cos theta 2. So this is the potential energy on electric dipole. The only thing is, what is the work done formula in rotatory motion? dW equals to tau into d theta. Instead of tau, PE sin theta. Integration of sin theta minus cos theta. If you are not taking limitations, simply we are taking electrostatic potential energy is the minus PE cos theta. So this is the potential energy on electric dipole in uniform electric field. This is the uniform electric field. Our fourth short answer question is, derive the expression for parallel plate capacitor. Many people are confusing parallel combination and parallel plate capacitor. Now we are discussing what is the capacitance of parallel plate capacitor. What is the capacitance? The ability to store the electric charge is called the capacitor. Now mathematically we have to give that what is the expression for capacitance in the case of parallel plates. In that question only parallel plates means we are taking how many plates? We are taking two plates. One is giving to the positive terminal of the battery, another one we are giving to the negative terminal of the battery. We should consider area of each plate is A and the gap between these two is D. D is the distance between two plates. Then how to derive the expression for this? First of all, you know that what is the capacitance formula in terms of charge, and that one C equals to potential, C equals to Q by V. C equals to Q by V. How to get the expression for C? In this case, look here. Two plates are there, one is giving to positive, another one is giving to negative. Then what is the intensity of first plate and what is the intensity of second plate? This is coming from the application of Gauss's law. According to that, here E1 equals to E2 equals to sigma by 2 epsilon naught. Sigma is the surface charge density. That formula is charge per unit area. is called the surface charge density, and epsilon naught is the permittivity of free space. Epsilon naught is the permittivity of free space. And here two plates are there. First one and second one, how much intensity is acting? Sigma by 2 epsilon naught. But total intensity is how much? E1 plus E2. We can write it sigma by 2 epsilon naught plus sigma by 2 epsilon naught. Half plus half is the full. So intensity is sigma by epsilon naught. So this is one step. But instead of intensity, what is the relation between intensity and potential? For this question we have to remember, we must know the concept. Capacitance formula is C equals to Q by V. And relation between intensity and potential is E equals to V by D. Surface charge density is the Q by A. When you know all these formulas only, we can able to derive the expression for capacitance of the parallel plate capacitor. Now just we can substitute all values. Look here. Instead of E, we are writing V by D. Instead of sigma, we are writing charge per unit area. This is called the surface charge density also. But our question is capacitance of a parallel plate capacitor. Capacitance of a parallel plate capacitor. So capacitance, what is the formula? C equals to Q by V. So one side we are getting the expression for Q by V. Look here, V, I am doing the cross multiplication. So we are getting A into epsilon naught by D. A into epsilon naught by D equals to Q by V. But instead of Q by V, we are writing C. C equals to A into epsilon naught by D. This is the expression for parallel plate capacitor. Generally, in terms of charge and potential, this is the expression for capacitance. When we are taking the parallel plate capacitor, it depends on the area of the plates and it depends on the distance between the two plates. Then our fifth question is, we discuss about the behavior of the dielectric material. Dielectric material means, don't confuse, it is nothing but insulator. What is the insulator? The substance which can not allow the electricity through it. That is called the insulator or dielectric. So suppose we are taking one dielectric. There are two types of dielectric, polar and non-polar. In chemistry also you know that HCl and all these polar, and H2O2, and those are the non-polar. Here we can take it. This is the dielectric. Dielectric means there is no charge. Charge is neutral. See, if there is no electric field, we can observe like this. Positive, negative. Positive, negative. Like that. Here we are not applying any electric field to it. We are discussing here behavior of the electric field in electric, behavior of dielectric material in electric field. Now, second step, this is giving to the positive and this is giving to the negative. Then what we are observing, positives is repelled by this one, and we can observe this is the negative. Side we can observe the positive. Then here negative. Otherwise this much. This is the negative. Now we applied how much intensity? E. Here induced intensity is making opposite this one. Then total intensity is how much? Original intensity minus induced intensity. This is the behavior of dielectric in the electric field. So according to new model from the Telangana state, we are expecting 2 S.A.Qs from the electric potential and capacitance, but total 5 are there. Prepare well, and I am giving the simple notes in description box also. Follow that one.